Alright, welcome to our next video in the circles unit. And today we'll be looking at other angle relationships in the circles. We looked at other angle relationships. We'll be looking at a couple more today. So we'll go ahead and get started with a theorem about the intersection of a tangent and a chord. If a tangent and a chord intersect at a point on the circle, then the measure of each angle formed is 1/2 the measure of its intercepted arc. So if I'm talking about angle 1 right here, angle 1 is going to equal 1/2 the measure of arc AB. And if I'm talking about angle 2 is going to be 1/2 the measure of arc BCA. So let's take a look at what an example might look like. So we have M is tangent at point A. And we get arc AB as the intercepted arc, and I want to find the measure of angle 1 right here. We're given that the arc of AB is 132 degrees, and based on the theorem that we just talked about, the measure of that angle is going to be 1/2 of 132. So the measure of angle 1 would be 132 divided by 2, or 66 degrees. Alright, in B over here, instead of being given the arc like we are in A, we're given the measure of the angle, which is 110 degrees. So angle D down here is going to be 110 degrees, and we're given the measure of arc. We want to find the measure of arc EFD. So we're just going backwards. If the angle is half the arc, that means the arc is going to be 2 times whatever the angle is. So the measure of arc EFD is going to be 2 times 110, or 220 degrees. All right, so if we have intersecting chords will intersect inside the circle. If we want to know measures of arcs or angles, we're going to use this theorem. And that is when I have 2 chords intersecting inside of a circle, the measure of each angle is going to be 1/2 the measure of the intercepted arcs. So, the measure of angle 1 is going to equal 1/2 arc DC plus arc AB. And if I want to talk about angle 2 right here, that's going to be 1/2 times the measure of arc AD plus the measure of arc BC. So let's do an example. We want to find the measure of angle X. So angle X is this central angle, or not the central angle, I'm sorry, this angle right here. And the intercepted arcs are going to be, so here's my 2 chords. The intersected arcs are going to be GH and FJ. Those are the 2 arcs that lie inside of that angle. Now X is going to equal 1/2 times arc 1 plus arc 2. So my 2 arcs that I have that are inside my angle are 140 degrees, which is arc GH, and 112 degrees, which is arc FJ. So 140 plus 112 is going to be 252. And then half of 252 is going to be 126. There we go. So it's basically the average of the intercepted arcs. Arc 1 plus arc 2 divided by 2. Alright, so that covers when we have an intersection inside the circle to find the measure of angles. But what happens when we have an intersection outside the circle? Now there's 3 different ways this could happen. So what we're going to do is we're going to have, when you have an intersection outside the circle, it can be a secant, it could be 2 tangents or 2 secants. Then the measure of the angle formed is going to be half the difference of the measure of the intercepted arcs. So this is, when it's outside the circle, I'm going to be subtracting the 2 arcs. So the first possibility is if I have a tangent and a secant, which would look something like this, and the measure of angle 1 here would be 1/2 times the measure of arc BC minus the measure of arc AC. I can have 2 tangents, which would look like this. And again, I'm going to subtract the two arcs. So it's 1/2 times the measure of PQR minus the measure of arc PR. And that would give you the measure of angle 2. And the last possibility, if I have two secants, I'm going to do 1/2 times arc XY minus the measure of arc WZ. So we're only looking for the arcs that are inside of the angle. And I'm going to take the bigger one minus the smaller one and then take half of that. So in example 3, we look at my diagram. I have a secant and a tangent. And the angle G is located outside of the circle. So we're going to need to subtract my two arcs. So x is going to equal 1/2 times the big arc, which is going to be JF, which is 170 degrees, minus my small arc, which is going to be HF, or 72 degrees. The arc HJ up here is not inside the angle, so we're not going to use that at all. So we don't need to worry about what that is. So 1/2 times 170 minus 72. 170 minus 72 is going to be 98. And half of 98 is going to be 49. So x is going to be 49 degrees. All right, go ahead and try the You Try Nows. As always, if you have questions, make sure you write them down on the side and ask them next time you see you. Have a good day.